Okay, so now we've got a question about complex numbers. We've got an argon diagram with the complex numbers Z1 and Z2 on it. And a bit of information here. I'll just have to read it. Okay, so they've said that the modulus of Z1 is R, and the argument of Z1 is theta, and we've got to find out what R and theta are. Let's look on our diagram, so I can see Z1 is here. Okay, so R is the distance from 0, the origin there. So that side's R. Now if you have a look, then I've got a triangle here. I know that side's 4, that side's 3, looking at the numbers on the axes there, and that makes that side 5. So R equals 5. Now I want to find theta. So theta is the angle made with the positive real axis in an anti-clockwise direction. So theta is that angle there. So if I look at that triangle, you can use sine, cos, or tan, but tan theta is opposite over adjacent, and then you could just use our calculator to get the angle 0.927. Remembering by default we tend to be in radians of complex numbers. Okay, right, now we're going to find the value of A, which is something to do with Z2. So if we have a look at Z2 down here, and we've got A is the value of the imaginary part. So the modulus of Z2 is 2 root 5. So that means this distance here is 2 root 5, and I can have a look at my triangle here. So this side's going to be A, this side of the triangle is going to be 4, reading off the axes there. So in order to find what A is, I'm just going to use some Pythagoras. So I'm going to work out 2 root 5 squared, subtract 4 squared, and that should give you 4. Okay, so square root of 4 is 2, but if you have a look at the axes, you can see that A is negative, so A must be negative 2. Okay, now they've introduced a new complex number, Z3. Okay, now Z3 has modulus R, an argument negative theta. At first you might think, what's that? Well, we already worked out they're meaningless are the same as the values we've already found. So R is 5, and the argument of Z3 is going to be negative 0.927, because theta was 0.927. Right, what does that mean? Well, Z3 therefore has a negative argument, which means it is now below the real axis. Okay, so Z3 is going to be there, there's going to be theta. It's got the same argument, so its argument is going to be 5. So Z3 is going to be there on my diagram. Once I've found out where it is on the diagram, the real component is going to be 3. As you can see, that's in the positive real direction. And the imaginary component, though, is going to be negative 4, because this is now below the real axis. That does mean overall, not that you asked for this, but Z3 is 3 subtract 4i. Okay, it looks like I've already answered part D already. So we've got a copy of figure 1. Okay, I've already actually plotted Z3, but for part D, we've just got to put Z3 in the correct place. So I know it's just a sketch, we've got to try and get it right. So it should be in line with Z1, because it's got the same component there, 3, and the negative 4 should be roughly the same distance from 0 as the 4 is up there. So you just plot Z3. Whenever you do anything on the diagram, you should label it as well.